Hadouken!
Come get some.
Hail to the king, baby.
I mean, with artificial intelligence, we are summoning the demon.
Hello, welcome back to A Boring Revolution, your number one news source for everything in regards to the Boring Company. Back to you with a very, very brief episode in regards to a very, very interesting development with the Boring Company. In fact, I would say this is a groundbreaking development because this is something that potentially could shape the future of the Boring Company and Proofrock. And I have been calling for this particular change in approach when it comes to tunnelling for almost 3 years now. So, as you can see, this is a video that I did in 2020, at the latter end of 2020. And basically, I've never shut up about this design change when it comes to concrete segments and the lining of tunnels for the Boring Company. I think hexagonal segments are very, very important because they enable two processes to occur concurrently. And for me, having programmed many construction jobs, nothing is better at shortening a program than having jobs occur concurrently. And considering that tunneling is very, very simple in terms of you do A, then you do B, then you do A, then you do B. If you can do A and B at the same time, then that is a massive improvement in efficiency and simplifies the entire process. So this video, I think, covers all the basics of hexagonal segments. So I'm not really going to go into the full details about that. But why am I getting so excited about this? So this is a flyover of the Boring Company site at Bastrop, and it's fascinating because, as you can see, there is a mock-up of a tunnel segment, and it uses hexagonal segments. Now, the Boring Company has used trapezoidal segments on its most recent projects in Las Vegas and the Hawthorne Test Tunnel. And this represents quite a significant move in a different direction. If you look at the overall tunnelling market in the USA, North America, even Europe, 99.7% of tunnels are done using either rectangular or trapezoidal segments, and hexagonal segments are just a very, very small niche area. And the technology really hasn't been looked at. Again, it's basically has stayed the same since the late 80s. And I've always looked at this approach and thought to myself, this has some fundamental drawbacks, but overall the positives massively outweigh the drawbacks. And this is the approach that the Boring Company should take. It's taken them a while to get here, but it was the obvious choice, and I'm extremely pleased that Steve Davis and the team at the Boring Company has made this decision. Just to confirm that these are trapezoidal segments, as you can see in the yard here, they have fabricated at least, I'd say 80, 90, maybe even 100 of these segments. They are all the same. They are the same dimensions in terms of width and length and the thickness. And this marks a massive improvement in the Boring Company's capabilities. I suspect that when they were talking about achieving continuous mining, it involves a new segment design. So all well and good. If you look at this particular tunnel here, it uses traditional trapezoidal rectangular segments. Here's another example. As you can see, you need to form a ring beam for this system to work with hexagonal segments. You can individually assemble each segment as its own individual structural element, and that for me is a massive game changer when it comes to building hundreds of miles of tunnels. Here's another example that I've used previously in the past with an example of how this system is used. This is a 4-piece design, as you can see. The example here is, I believe, a 6-piece design. The Boring Company has gone for a 6-piece design. That offers a few advantages over the 4-piece segment design in terms of how you dissipate the loads when you're thrusting the machine forward. I'm trying to keep this episode as short as possible, guys, so I'm just going to move through this. So again, here's another great example of hexagonal segments. This is a 4-piece design. Here's another illustration. Now this has a slightly different setup, but this is very, very similar to what the Boring Company is going to be using. So before we terminate this video, I just want to tell you a quick theory that has been going through my my psyche, as it were. As you know, SpaceX were not the first company to successfully launch and land rockets. It was this particular prototype. It was never really used. It was a prototype. It wasn't like a full-on production rocket like we've seen from SpaceX. But the McDonnell Douglas DXX, or Delta Clipper, was a great example of someone coming up with an idea and then putting a lot of work in, but not refining the idea so that it could become the standard today. And obviously SpaceX took the learnings from this particular project, applied it to their own business model, and Bob's your uncle, they are now by far the largest rocket company in terms of launches per year than the next 10, 20 combined, if not the entire world. Another fantastic example of this. If you look at those circuit boards behind me, a lot of them are Acorn circuit boards. And Acorn Computers was a very, very large company in the UK that manufactured computers in the 80s and 90s, and they were the first company to really produce an excellent computer using an ARM processor. Now, unfortunately, they didn't push that further forward. The business model didn't quite work, but they did produce some very, very good machines. And unfortunately, Intel then took over the entire market in 1998 and were the dominant player for many, many years. They had all the profit. They had a great idea. But the ARM processor was the better design. This computer in front of me has an ARM processor. Every mobile phone that you've probably ever owned has an ARM processor. So it's a great example of an idea that was great, wasn't quite executed properly, but then because people looked into it again and realised the benefits of using an ARM processor, they went back to an old idea and then it thrived and it became the dominant, just like the McDonnell Douglas. I think that is what's going to happen here with our hexagonal segments. I may be wrong, but I've been pushing this idea for a very, very long time. The fact that the Boring Company has taken this approach as well kind of vindicates all the videos that I've made about hexagonal segments. But just to basically summarize, the advantages of hexagonal segments enables continuous mining and thus faster construction. So we're expecting well over 100 meters per day if you average it over the course of say a month. Can be assembled piece by piece rather than ring by ring. So instead of assembling that ring beam, you're assembling each piece, and then you can use each piece to thrust off. Every concrete segment is the same dimension. It doesn't matter where you put that segment, it's always going to be the same. Unlike trapezoidal systems where you have 3, sometimes even 5 different types of segments, it complicates things. The best piece is no piece. The best part is no part, sorry. Less segments are required per mile of tunnel. Why is that important? Well, if you're having to lift that segment with the erector, you're having to do less lifts. That is resulting in less maintenance for that particular erector. Less movements is more efficient. Grouting and repairs are a quick way to watertight, vacuum tight a system. So essentially the disadvantage of this is that it doesn't come out as a watertight tunnel from day one, but you can make it watertight, and doing so is fairly affordable, and that work to make it watertight can be done concurrently with the construction of the actual tunnel. So it doesn't really qualify as a negative, as it were, but I will put it down as a disadvantage. So disadvantages: requires a thicker, more robust concrete segment, because obviously you're putting more stress on each segment. You're not dissipating that load as well as with a ring beam, so each one needs to be thicker, needs to have more reinforcements, maybe needs fibre reinforcements, maybe needs a specific concrete mix to ensure that you don't see stress fractures. A tunnel's curve radius is limited to 120 metres. It's very difficult to use hexagonal segments in a straight line, but I think with the 6-piece design that might be much better. So you're looking at around 120 metres minimum for a curve radius. Slippage at the joints can cause water ingress and costly remedial work. Now, certainly if you were working in an area that had a very high water table, the remedial work would be non-stop, and you'd be constantly repairing the segments. But if you were able to create a system of temporarily patching up those areas and then coming back at a later date, maybe you could significantly reduce the costs. But it can be costly depending on how much the actual joints move. If it's fairly minimal, then those costs will be fairly small. It's difficult to say until the boring company starts using this method. We won't be able to tell how costly it's going to be. It might be a very minor issue, it might be a major issue, it might be somewhere in between. Some concrete segments will develop large fractures, cracks after assembly. So ultimately, all that additional pressure that's coming from the thrust cylinders may cause some segments to crack. Potentially, you might even see some spalling, but it's unlikely. And then you'll have to come back later on and remedy those defects. But it can all be done, and while that's happening, your TBM is progressing forward at a very steady pace. So for me, the advantages massively outweigh the disadvantages, and there's many methods you could use to kind of limit these disadvantages. This doesn't matter too much. I mean, it doesn't really matter. It's not going to add. It might add maybe 5 to 7% to the cost. That's the only issue with that. If you have a good system, slippage could be as little as 7 or 8 millimeters. So that might be a non-issue that I later remove from this list. And inevitably, segments do get damaged during construction in all systems, but it might be slightly more prevalent with hexagonal. But you can come back at a later date and repair those segments, and it's not really a big deal. That might add maybe 1 to 3% to the cost of the overall job, which really isn't going to break the bank. Okay, everyone, thanks for tuning in. Trying to keep this video as short as possible. Please like and subscribe. Please consider supporting me on the above platforms. As always, Patreons much appreciate all your support. It really does help. And remember, guys, don't be boring. We will see you on the next one. Take care now. Goodbye.
Hail to the king, baby.
Tiger uppercut, perfect.